Welcome to Gamer Chair Philosophy. We are going to get into a deep dive into Portal and the philosophy of science. Now, I'm uniquely qualified to talk about this subject because I graduated with honors not just with a biology degree, but with a philosophy degree. And here I am making YouTube videos. This is something that's been interesting to me, having a foot in both worlds, where you have the hard science on one side and you have the lofty philosophy on the other. Well, where do they intersect? And what the heck does this have to even do with Portal and Portal 2? More Portal 2. Well, let's get into it. I want to focus on the recordings of Cave Johnson and the ending song from GLaDOS. Both of these are going to give us insight into Portal's mastery and understanding of the true nature and true goal of science. And it wouldn't be one of my videos if I didn't get into a little bit of the history and just some of my own personal experience, because I always laughed at people saying that they're studying philosophy because philosophy is stupid and science is king. When I was going to college, I was studying science, and I was part of the honors program, and I had to take some dumb philosophy classes, and so I was like, okay, whatever. And I got sucked in. I dipped my toe into that dark goo and it just pulled me right in, or like Nietzsche says, I stared long enough into the abyss that the abyss stared right back at me. That abyss being philosophy. The more I studied philosophy, the more I had the realization, which is probably the obvious one, that science and philosophy share the same roots. When you're looking back at pre-Socratic philosophy, we're talking thousands of years ago. The same people who were figuring out the circumference of the earth by measuring the shadows that were cast by obelisks were the same people theorizing about the nature of matter, the nature of being. People like Thales, Heraclitus, Parmenides, Empedocles. You have these, and I'm really Western-centric, Greek-centric on this, you have the thinkers of the past, these philosophical juggernauts that aren't just sitting there asking the questions why in the sense of like philosophy. They're asking the big questions as part of natural science. They want to know, what the heck is the earth? What is it doing? How do I describe the things that I see and that I experience? And you go down this tradition of these philosophers and scientists. You get to Plato and Aristotle, where there's a dichotomy where Plato is all about the abstract, talking about his forms. Aristotle is all about concrete reality, looking at what do you see with your own eyes and basing your philosophy off of that. Now, he still had lofty ideas like the prime mover. He still had stuff called metaphysics. So he still wrote about more philosophically inclined stuff. I point to Aristotle and Plato as the beginning of the schism between philosophy and science. And this schism wasn't a hard breakup. It wasn't a terrible divorce. It kept on going until the Renaissance, into the Europeans with Descartes. He was one who was thinking about the meditations on first philosophy while also vivisecting cats. He was focusing a lot on identifying the nature of the soul. What does it mean to exist? His idea was that the soul would use your pineal gland as a punching bag, or as like a ratatouille type thing, to puppet your meat sack of a body. You see this historically, science and philosophy being hand in hand. Scientists were called natural philosophers. And it wasn't until the 1800s, mid-1800s, when you see this hard separation between the two. Now that we have the idea of science and philosophy separating in the mid-1800s, well then what becomes the goal of science and philosophy? Because philosophy is going after the big questions. Why are we here? Why do we exist? What's happening? They're going after big T, capital T, truth. What about science? Science, contrary to what you may think, is not a search for truth. Science can't determine what is true. You see what's going on around you, and you always have to have an element of doubt in your perception. Because what if, I'm going Cartesian on you, what if your eyes have deceived you? What if your perception has deceived you in some way? So whenever you're observing natural phenomena and trying to figure out what it is, big T truth isn't possible here because there is an unreliable narrator. You, an unreliable observer. You. The way science deals with truth is the same way as an asymptote. Now, an asymptote is a curved line that slowly but surely gets closer and closer and closer and closer to a point. I'll just show it here as like a line on the x-axis. The line comes infinitely close to touching this x-axis, but it never actually crosses it. They never touch. This is how science approaches truth. Big T truth is out there, science is just blind to it. And all of the experiments, all of the testing that is done gets us incrementally closer to that truth, but the underlying assumption is that full truth is impossible. Even with an overabundance of evidence, science does not say that, hey, here is a fact. We say it's a theory. And people shoot this down all the time. All of the idiots will shoot this down saying, well, it's just a theory of evolution. No. We have like 99.999% certainty about how evolution works. It isn't in dispute. But because you're a scientist, given the off chance that you have perceived something wrong, that there's something still out there that could disprove your data, no matter how unlikely it is, you can't have the arrogance to say that evolution is fact. You always leave a little bit of doubt, the devil's advocate as it were, giving you a backdoor because you never want to be, in theory, tied to a theory. You always should be challenging it. And the way you challenge these theories is through hypothesis testing. Hypothesis testing is a philosophical concept, really deeply philosophical, because the idea is that when you're collecting data, your aim is to either reject the null hypothesis or your assumed hypothesis, or you fail to reject your null hypothesis. This is the important distinction. You don't ever prove that your hypothesis is true. You fail to disprove it. This is the key to understanding that science cannot have access to truth. It can only generate an approximation of truth by disproving what isn't true. It can show you what's not true, and it can't show you distinctly what's true, but you can fill in the gaps. Cave Johnson can summarize this a lot better than I can.
Science isn't about why, it's about why not. Why is so much of our science dangerous? Why not marry safe science and love it so much? In fact, why not invent a special safety door that will hit you on the butt on the way out because you are fired? Now you test subject, you're doing fine.
And I'm going to tweak his words a smidge here, but when he's saying it's not about why, it's about why not. Whenever you're doing hypothesis testing in science, you're not proving why something is, you're proving why something is not the case. So for all you flat earthers out there, we have proven that the earth is not flat. But funnily enough, we haven't proven that the earth is spherical, just due to the nature of science. And it's not even spherical, but you know what I mean. The idea being that we discard falsehood, we discard things that aren't true, and move forward, and by carving out the stuff that we know isn't true, isn't correct, we get an approximation of what is true, but it's just that, an approximation. A key side effect of there being no truth in science is that science is very myopic. It's very short-sighted. Yes, there is predictive power in the models that science has created. The discovery of Neptune was because we had a theory of how stars and planets and gravity interact with each other, celestial bodies all interact with each other, and we noticed some aberrations in orbits, and we thought, there must be something planet-sized here. Turned our telescopes to that spot, looked closely, and boom, we discovered Neptune. So yes, there is predictive power within the models that exist in science, but we do not anticipate very well. We don't know the future. Science doesn't have a crystal ball. Some examples. Simon Newcomb, he was a Harvard graduate scientist. He published an article on the impossibility of flight, saying it'd be like 1,000,000 years before flight would even be possible. Well, 2 months later, the Wright brothers flew the first plane. Ignaz Semmelweis, sorry dude, I don't know how to pronounce your name. He was an obstetrician, well he was a physician, but he dealt with pregnant women, and there was a scourge at the time where women would be dying after childbirth. It was a massive number. Doctors were perplexed. Why are these women dying? They would get these fevers and then just die, and they just took it to be, well, that's just what happens. Dr. Ignaz, bless his heart, he started implementing a process of washing his hands after seeing one patient and going on to the next patient. This dramatically reduced the number of deaths of the women in his ward. And then he started telling everybody else, hey, start washing your hands. And you know what the scientific community did? They called it witchcraft. They made him so insane, he died penniless in an insane asylum because his ideas were so radical, he was ostracized. He was a pariah in the scientific community just because hand washing prevented the deaths of these women. Now hand washing is the standard, but no one knows the guy who invented it. And and science laughed in his face and shooed him out of the room. Science cannot anticipate new discoveries. In the modern era, a company was looking at creating a new allergy medicine, so they gave this medicine to people in clinical trials, and unfortunately it didn't really work too good for allergies. However, people were a lot less depressed. They dug into it a little bit further, and that's the birth of SSRIs. Selective serotonin reuptake inhibitors. I'm a true scientist. In Portal 2, I saw something very similar to this with the repulsion gel, so I stopped and was looking at the artwork, and I read this blurb, and it reminded me of the discovery of SSRIs. The stuff that you're bouncing around on was actually developed to be a dietary aid where the food would bounce around in your belly and shoot out of your mouth, which was not a great idea, but it was really great at getting people and you to bounce off the walls and wherever this thing was sprayed. So Portal 2 is much closer to reality than you would think.
Oh, in case you got covered in that repulsion gel, here's some advice the lab boys gave me. Do not get covered in the repulsion gel. We haven't entirely nailed down what element it is yet, but I'll tell you this, it's a lively one, and it does not like the human skeleton.
But the intent of testing this allergy medicine, ending up with a new drug to treat depression, is a perfect encapsulation of throwing spaghetti on the wall and seeing what sticks. Just like Cave Johnson.
Just a heads up, we're going to have a superconductor turned up full blast and pointed at you for the duration of this next test. I'll be honest, we're throwing science at the wall here to see what sticks. No idea what it'll do. Probably nothing. Best case scenario, you might get some superpowers. Worst case, some tumors, which we'll cut out.
So the role of science is, or the goal of science is not truth. What about good? I'm talking in the moral sense. Well, spoiler alert, science is not dedicated to figuring out what is good. Science works independent of morality. And there's a lot of historical examples of philosophers, i.e. David Hume. I have an axe to grind with David Hume, but one of his more famous ideas was the idea that you cannot derive ought from is. His work, A Treatise of Human Nature, goes into this problem, and I'm going to be paraphrasing a lot of this section. The idea being that as people are talking about reason, perception, they start using words like is and is not. It is the case that the sun is yellow. It is the case that the sky is blue. They start from an objective standpoint, and then slowly but surely, they start switching the ises to oughts and the is nots to ought not, which is a subtle distinction, but it is of huge consequence because where do they get the moral element from a bunch of facts? He closes the section by saying that the distinction of vice and virtue is not founded merely on the relations of objects, nor is perceived by reason. Meaning, the way that we assign the categories of vice, virtue, isn't derived solely from factual occurrences. There has to be something else that's used from the facts in order to give you morality, but the facts alone don't get you there. Ought is a moral imperative. Thou shalt. Think of the 10 Commandments, right? Thou shalt not murder. Well, you don't get to that axiom, you don't get to that moral idea through science. Science is a collection of facts. Science is a collection of ises. So whenever you're looking at a bunch of facts, a bunch of ises, you can't get morality or oughts from that. Let's take thou shalt not murder. In modern society, we generally frown upon murdering people. Why? Not being like an edgy teen. Why? There's no data that shows that murdering is evil. We know that murdering kills people, definitionally. But really, why should you not murder? What if you murdered somebody and didn't get caught? Should it always be that you should not murder? Well, let's take the example of Ken McElroy. He lived in Skidmore, Missouri, and he died in 1981. He was a town bully, he was an attempted murderer, he was just an overall terrible person. One day, he was just dead in his truck, all shot up to pieces. And no single person in that town knew who did it, wink wink. Killing people has exceptions. It's not always the case that killing is bad. There's always another greater good or what have you, better serving the community. There's always exceptions to these rules, but if you're trying to take a factual, scientific basis to extrapolate into morality, there's nothing to bridge that gap. Try as you might. You only have morality because it is what you choose to believe in. It's either dictated to you by God or it's dictated to you by your culture. But if you want to eschew cultural norms, discard God, you can do whatever you want, right? And this is the radical postmodern atheist nihilistic mentality. But this is kind of, at some level, it's true. You can't just use science to figure out whether or not something is good or bad. Science doesn't have the apparatus to generate morality. And I'm looking at you, Sam Harris. Sam Harris is a big proponent that you look at, what types of culture, what types of practices lead to the flourishing of a society? Well, you can generate a morality from that if your end goal is flourishing of a society. But what if you're talking about flourishing of yourself? Why would you want to play fair? Why would you want to not murder your competition? Why wouldn't you want to be depraved maniac? Just because you've picked your endpoint as the betterment of a society. Who cares about society if I'm going to die and it's all going to disappear? And science itself is not moral. I'm not saying that they're amoral, where they are incapable of morality. They do a lot of heinous stuff. Let's go back to Cave Johnson talking about nanoparticles.
For this next test, we put nanoparticles in the gel. In layman's terms, that's a billion little gizmos that are going to travel into your bloodstream and pump experimental genes and RNA molecules and so forth into your tumors. Now, maybe you don't have any tumors. Well, don't worry. If you sat on a folding chair in the lobby and weren't wearing lead underpants, we took care of that too.
We wouldn't ever do that, right? Right? We wouldn't do that. Well, it wasn't the United States, but the Nazis really did some heinous shit. One of the things they did in the concentration camps was they took 400 of the prisoners with syphilis, and they just watched and waited. They had cures, and they just didn't give it to them. They wanted to see what syphilis would look like when it was untreated. For years they were watching this and just let it happen. In another concentration camp, they took 107 families and put them into shelters, but they used lead paint in the shelters because they wanted to see what would the effects be of long-term lead exposure. Because they knew lead was dangerous, but who cares? They're just Jews to the Nazis. They knew lead was dangerous, and they just wanted to test it out on some unwitting subjects who couldn't choose otherwise. No harm, no foul. Except there was harm, because there was 140 children in these groups that ended up with severe neurological disability and nervous damage that was permanent. Wait, let me check my notes really quick. Actually, that wasn't in concentration camps. That was in the US. One of them by the US government and the other by Johns Hopkins Hospital. The Johns Hopkins. The Tuskegee syphilis study was going on from 1932 to 1972. They took black men aged 25 and older and told them that you're going to be part of a special government healthcare program. Turns out it was just a way to see what untreated syphilis would do. After penicillin was developed and readily available, they just withheld it from these men who didn't know any better. President Clinton even did an apology for that. And the Johns Hopkins lead paint, well, they took a bunch of low-income housing and decided not to treat it for lead paint because they wanted to see what would happen if children were exposed to lead. Not only was it low-income housing, but they offered financial incentives to these poor people to move in. This was in 1993, the year of our Lord. This wasn't some distant past. This is recent history we're talking about here. What about gain-of-function research? Gain-of-function research is all about attempting, and I'm not being an anti-vaxxer here, so shut up. Gain-of-function research is all about anticipating what a virus is going to do. What happens if a virus becomes extra deadly? What happens if a virus becomes extra virulent, where it can spread wide and far? What happens, so Ebola, if you get Ebola, it's a death sentence. The problem is, unless you're like eye-to-eye contact with someone with Ebola, you're not going to get it. What happens in the off chance that Ebola becomes airborne? So scientists try to initiate these changes in viruses to see what would happen. In the worst case scenario, Ebola goes airborne. Ebola becomes easier to catch. We would be caught with our pants down if we didn't have a solution to that problem. So what do? We give these viruses the ability that they don't have to jump species, to be more virulent, to be more infectious. And what's the risk? Well, COVID-19. This is why, for most research, unless you're government funded, you have an internal review board, an ethics board, where you can't just run experiments willy-nilly, or you shouldn't run experiments willy-nilly. You have to present it to a board, an ethics committee, that'll tell you whether or not what you're doing is heinous and wrong. If they say no go, you can't do it. So a lot of clinical studies on humans have to pass through an IRB, and you have to get approval from an ethics committee to make sure you're not violating human rights, not because we're being nice, but because time and time again, we have violated human rights in the pursuit of science. Now, finally, what is the true aim of science? Merely to do more science. Roll the clip, Jimmy.
And again, welcome to the Aperture Science Enrichment Center. We are currently experiencing technical difficulties due to circumstances of potentially apocalyptic significance beyond our control. However, thanks to emergency testing protocols, testing can continue. These pre-recorded messages will provide instructional and motivational support so that science can still be done, even in the event of environmental, social, economic, or structural collapse.
Science is only existing to do more science. That is why you have these esoteric, apparently wasteful research things of reading tea leaves and how do tea leaves fall in a cup? What does it matter? Well, it doesn't matter. It doesn't benefit humanity. Who cares? The only thing it benefits is that now we know how tea leaves settle in tea. There's tons of weird examples of seemingly inconsequential research, but the idea is that inconsequential research is still research. It's still science. Science exists to do more science. So whenever you're thinking about the philosophy of science and Portal, you have these seemingly random tests in Portal where you're just trying to cross a room, right? What could possibly be the point of figuring out how to cross a room? That's exactly the point. There is no point, but it is knowledge for its own sake. And in both games, you're figuring out puzzles just to solve the puzzles. And even Wheatley at the end, he's developing this itch for science where he needs to experiment, he needs to figure out, he needs to run tests. Why? For the sake of running tests.
You have no idea what it's like in this body. I have to test all the time, or I get this itch. You know, it must be hardwired into the system or something. Oh, but I tell you, when I do test, oh man alive, nothing feels better. It's just, that's what I've got to test. That's what I've got to test.
There is no such thing as useless knowledge. Any knowledge is useful. Whether a test succeeds or fails, whether you live or die, something can be learned and can be applied to the next test that you run. And you constantly iterate and iterate until you get closer and closer and closer to a full understanding of the universe. Whether that means chugging bottles of bacteria, jumping through portals, or throwing yourself into a volcano, there is no loss for science. If it was recorded, if it was written down, it's a win. And now we can finally talk about GLaDOS and the magnum opus of her final song. And even though she's dead, even though she's been killed, she really gets, her and Cave Johnson, they're the true scientists. Because even though she died, she's saying,
"This was a triumph. I'm making a note here. Huge success."
This is a triumph, huge success. Why? Because we did science. Science was accomplished, something was learned, hooray. And now as we jam to the song, we do what we must because we can. This ties back to what I was saying about science being unfettered by morality. Science isn't about good. Science is about figuring stuff out because you can. Why study some random protein in a cell and name it Sonic the Hedgehog? Because you can. Who freaking cares? You're getting more science done. And, hopefully you're not killing people along the way. And this right here is hypothesis testing in a nutshell. Every mistake, there is no such thing as a mistake. This is where Thomas Edison comes to mind, where he didn't figure out how to invent a light bulb. He figured out 1,000 ways to not invent a light bulb. But you keep going, you keep doing your hypothesis testing, and the science gets done and you make a neat gun, which, is a lot of science. But even then, you do all the science to make some weird thing, and then you keep going for not even, the one thing I will say is that it's not for the people who are still alive. It's for the sake of science. And then GLaDOS gets into the part of her being dead. So I'm glad I got burned. Think of all the things we learned for the people who are still alive. Funny enough, this too has a real life counterpart. There are some ballers in science, and one of them is a doctor named Barry Marshall. In ancient times, 1982, we were trying to figure out what caused stomach ulcers. And it was believed that there were no bacteria that would cause stomach ulcers because the stomach is too acidic. The stomach contains hydrochloric acid. that melts stuff. So there's no way that there'd be anything living in your gut that could cause ulcers. Well, Barry Marshall and Robin Warren, they decided no, that's not true, but they couldn't get funding to do the test because of an IRB of giving people H. pylori and seeing what would happen. So, rather than wait for pesky science, Barry Marshall decided to chug a test tube full of H. pylori, developed ulcers, won a Nobel Prize. At the end of the song, I have experiments to run, there is research to be done on the people who are still alive. Research is its own end. Science does not exist for the benefit of humanity, for the search of truth. Science exists only to perpetuate itself, at any cost. And in the immortal words of Cave Johnson,
They say great science is built on the shoulders of giants. Not here. At Aperture, we do all our science from scratch. No hand-holding.
okay, I made it to the part that no one gets to. I'm sorry for the delay. I really had a lot of stuff going on the real life side of things, and I have a lot of videos prepped, and I'm excited to get them out. I have a whole series on Bioshock that's going to be coming out. I think it's going to be about 3 videos, maybe more, but I'll start busting those out. I've had to read a lot of books to get here, so that's what I've been doing in my off time and also just living life. So appreciate all the new subs, and I know this is a left turn from the last video, which was a left turn from my normal content, so we're back to normal. Woohoo. Subscribe and love me, please. I need it.